All right, I've already put all the numbers in from this problem. And I'm going to tell you how I got them there. What we're doing now is a lot like what we did before with two-dimensional motion. We're just adding this one little angle column and figuring out the sides of the triangle when we do that. So I'm going to refresh your memory about how to do two-dimensional motion stuff, and then I'll do the triangle. So this thing told us it was launched at an angle of 10 degrees, which is 10 degrees up from the horizontal side. So we put it in the horizontal angle box. We're not going to fill out this box. It says its total flight lasted 0.6 seconds. You can see that. So its total flight is from when it was launched to when it landed. Before, we were just doing the fall part, and on our y stuff, initial velocity is always 0, and it's still always 0. All this y stuff is only worried about the fall. So when it talks about the total time of the flight, that's from the beginning to the end, so that's always the x time. So if its total time was 0.6 seconds, that's why I put the 0.6 right there. And if this total thing lasted 0.6 seconds, then just the fall part of it, just the vertical fall part, that's 0.3 seconds. And that's why I've got 0.6 seconds there and 0.3 seconds there. And just like before, gravity doesn't work horizontally, so acceleration for x is 0, acceleration for y is -9.81, and 0 is the vertical initial velocity. And all these three, I'm going to circle them so we can remember that. All these three, just like before, are always the same on every chart. All right, now we're ready. See, that didn't take too long. I got my marker cap off. It's going to ask these questions just like before, and we'll do these three little ones. First, use horizontal values to calculate horizontal velocity. So it's in a different order, but we're calculating horizontal velocity over there. Notice it didn't say calculate initial or final velocity. Just are you paying attention here? Because acceleration for x is 0, vi and vf are going to be the same as each other. So just like before, these two boxes will always be the same as each other. But because vi and vf are the same as each other, we don't really need to specify it's vi or vf, so we just say v. And that means we can use this formula, which makes it a little easier. Let's see if this marker works. Anyway, since we're finding something that's horizontal, we've got to use only the horizontal stuff. The vertical stuff has nothing to do with how fast or how far things are going this way. So what I got horizontally, I got distance is 10, and time is 0.6, and it's asking me calculate horizontal velocity. So it's asking me for v. Remember, it's just v instead of vi and vf. Since they're the same, it's just v. So I'll use that formula right there with just the v, and I'm looking for v, so I just write v. Displacement is 10, time is 0.6, and 10 meters divided by 0.6 seconds makes 16.7 meters per second. And remember, that goes in both spots up here. 16.7, 16.7. So I'm trying to color code this. I got the blue marker was the stuff that it already gave us. The black marker is this horizontal stuff we did. Now, this one's going to be purple. It says use vertical values to calculate vertical final velocity. Okay, vertical is y. Final velocity is over here. So it's this box. Since this box is a vertical box, it's on the bottom row, we can only use these vertical values that we know. So I'll write those down. Time is 0.3. Acceleration is 9.81. And initial velocity is 0. It's asking for final velocity, so I'll write vf equals blank. The easy formula to use here, and it's the one we always used for this box before, is this VF equals VI plus AT. We're looking for VF, so I'll just write VF. VI is 0. Acceleration is negative 9.81. And time is 0.3. If I plug all that in the calculator, it gives me negative 3.924 meters per second. And that's what I put there. Okay, so I've got black marker goes with the black number, purple marker goes with the purple number. Next, green marker. Y'all still with me here? Okay. Yeah, this is like what we did before, and then we're gonna do the stuff that we just did with the triangle stuff. So okay. Use vertical values to calculate vertical distance. Alright, that's the only box we have left. Vertical distance, it's on the Y row for vertical, and it's on the distance column. Here we go. Man, I got a lot of vertical values now. Oh man, what I got? Time is 0.3, acceleration is negative 9.81, initial velocity is 0, final velocity is negative 3.924, and it's asking for distance. Whew. It's a lot of things. So because there's nothing it doesn't mention, I can use any formula I like as long as I can solve for displacement, so it's got to have displacement in it. So I guess I've got a choice between this one and this one. This one I'd have to do algebra to solve for displacement, so I'm going to use this one because it's just D equals. I just put this in and press enter and I'm done. And that's the one we used to use for that too. That's why we ended up using that one, because it's the easy one for that. So we're looking for displacement. Initial velocity is 0. Time is 0.3. 1/2 is 1/2. Acceleration is negative 9.81. And time is 0.3. Don't forget it says t squared. I know, people, they write all this stuff out and they're like, whew, I'm done. But there's still a squared. You're going to mess it up if you don't remember that squared there. All right, if you plug all this in, you got your negative there. Don't forget, this will be negative 0.44 meters. So, there's your vertical distance. Remember, everything that can be on the vertical row should be negative. So time can't be negative because that doesn't make sense. 0 can't be negative because that doesn't make sense. But displacement can be negative because that means it went that many meters down in the down direction. This means that acceleration's in the down direction, and this means that final velocity is in the down direction, it's falling down. Cool.
I'm good.
That's all the stuff that we've done before. Now I'm going to show you this triangle business. Now I'll put this back up there, but you may want to take a screenshot or pause the video or whatever if you're doing anything. But I'm going to scroll down.
No.
I'll put it back. I'll put it back. Don't worry.
He saw you start quake, like,
Anyway,
Right
no,
as I took the picture, he switched the screen.
did you get it?
No.
Oh, sorry. Well, I'll put it back. It'll be fine. I was mostly talking to the people at home. Here we go. So we got the where are we? We're doing the triangle here. I'm gonna use the black marker just because it's got high contrast. And I'm gonna draw my triangle a little bit more to scale this time. No, don't mess up my deal here. Not allowed. Let's see here. Oh, that's not a very good triangle. Pretend that this is a good triangle. It already told us it's got an angle of 10 degrees. And let's see what it actually says before we do stuff. Use the velocities found for the table at the top to label a triangle. calculate and label the angled velocity at which the marble was launched. The angled velocity means it wants this side of the triangle. So we're looking for the hypotenuse. That means it wants us to label these sides with the velocities we found. A lot of people get real confused with this, so I'm glad you're watching the video here. This is the horizontal side, so this will be your x. It's asking for velocity, so that means that this will be x velocity and this will be y velocity. X velocity is a little easier to get from the table up there because there's only one number for x velocity. Initial and final both say 16.7 on it. Let's see, this is next to the angle, so this is my adjacent side. And horizontal velocity is 16.7. All right. Vertical velocity, we've got two vertical velocities in the table. We had 0 for initial velocity and negative 3.9 for final velocity. This side has some length that's not 0, and we're using the one we calculated this side. So we're using, this is the opposite side, and that, maybe I can write that right here. The opposite side is 3.924 meters per second. Now I know we got negative 3.924. I'm putting positive 3.924 because we're finding the angled velocity at which the marble was launched. So we're finding this velocity down here in its path, its whole path. Can you see better now, Aiden? We're finding this velocity right here. Before, the vertical velocity we found was its vertical one right as it hit the ground over here, and that was in the down direction. But it makes sense if this side matches this side. If it falls from 0 and gets to negative 3.9, that means if it ends at 0 on this side, then it started from 3.9. So that's why I'm doing this. Really, we're making a little triangle right here that says, okay, this side's 3.9, this side's 16.7, and we're going to find this side using the angle 10, like that. But this triangle's really small, so I guess I can leave that there. I can leave that there. 10, 3.9, 3.7. All right, so let's try it out. We're trying to find this one. We've got the opposite side and the adjacent side. A lot of people say we've got O and A. If I'm using SOHCAHTOA, O and A go with T right here. So I need to use tangent, but that's not right. Who's there? So, even though you've got O and A, we're looking for this angled velocity, this sideways side here. What am I saying? Diagonal side, not sideways. And that means we need to have this in the formula. Just like when we were solving for displacement, we needed a formula that had displacement in it. If we're solving for this side, we need a formula that has h in it. So it's either sine is opposite over hypotenuse or cosine is adjacent over hypotenuse. It can't be this one because there's no hypotenuse. So let's see, I need somebody to pick a side. We got opposite side and adjacent side. We can either use O to solve for h or A to solve for h. Okay. We almost said O? Oh,
Yeah.
I was going to call on somebody. All right, O. So if we're using O to find h, O and h go with sine here. So, oh, no puns. No puns. We're trying to find h,
So
right, this side.
Isn't it more easier to do 16.7 squared plus 3.924 squared and then add them together and then divide by
Yes,
square?
yeah, but we're not in 6th grade anymore, so we're doing, we're doing trigonometry. It's a good way to check your work, though. If you want to do the Pythagorean theorem to check your work for this, then that's a good way to do it. So, if we're using O to find h, O and h go with sine, so write your sine formula. Oh, come on, marker. And let's see. Now we're ready to plug stuff in. our angle is 10, so for theta, I'll write my 10. This is stuff y'all were just doing. And the opposite side is that 3.924. And hypotenuse is what we're looking for. This is where it gets tricky because remember, when you have anything in the denominator that's something you're supposed to solve for, it makes it difficult to keep everything straight, and it makes it difficult just to do it if you keep that there. So we need to make it cancel.
You have to multiply on both sides.
Good, yeah. It says divided up by hypotenuse, so we need to multiply both sides by hypotenuse to make that cancel. And now it's not down there anymore because there's one on top, one on bottom. It canceled. So now what we've got is hypotenuse times sine of 10 equals 3.924. So we're almost there. We wanted to say hypotenuse equals, and then whatever we get will be done. It says hypotenuse times sine of 10. So we've got to make that cancel. Since it says times sine of 10, we'll divide both sides by sine of 10. Now a lot of people think, oh, I'll divide both sides by 10 because it's a number and that would be easy. But sine of 10 is a function. You got to keep it all together, all with itself there. Think about like if you put sine of 10 in a calculator, it'd give you a number. Are you awake? So pretend like you already got that number and you're dividing both sides by whatever that number is going to be. So it says times sine of 10. I'm dividing both sides by sine of 10. One on top, one on bottom. So on the left, it says hypotenuse equals. Now that these are gone, I just got to put that in the calculator. And I don't remember what it is. So what we got? 3.924 divided by sine of 10. Okay. Nope. I got a new calculator on my home screen, and it's great. No. Oh no. I'll do it. Here we go. Okay, I got 22.6. And that'll be fine. Because my other sides are in meters per second and meters per second, that means this side has to be in meters per second also. So there we go. And that's how you do all of that. You put what you knew with the two-dimensional motion, and then you add this trigonometry stuff, and y'all's assignment is going to keep that separate also.